All right. Hello, everyone. This is Makayo. I'm doing our walkthrough for Lab 10, Spatial Interpolation. Interpolation is used to fill in the gaps of our data sets, so it's really good for point data that doesn't necessarily cover the entire area that you want it to. And to do that, we're going to be using three different tools: the IDW, the inverse distance weight tool, the spline, and the kriging tools. If you have any questions about how these tools work or how they're used, please click on these links and they'll help you out more with that. But with that said, I'm going to get started on the walkthrough. And all right, first things first, let's deselect our base maps. And we're going to be using the IDW tool on our ripple feature with a random z value field of random. So we're going to be creating a lot of rasters this lab, so I recommend adding some kind of signifier at the end of your output raster name to help keep track of everything that you're creating. But I have my IDW done. And then next, we're going to be using our spline. So it'll be the same thing. We have ripple, random, spline, ripple, Q3. Let's run through this one more time. And then we're doing our kriging. Our Z value field can be random, and our output surface raster needs to be updated as well. So Q3, let's run. And all right. So these three tools created rasters of our point data. And okay. So looking at our data from the IDW, we can make out some areas that have higher associations than others. Our spline do the same thing. But if we carefully go back and forth, there are some differences between our IDW and our spline values. So yeah, something to take note of. And then finally, our kriging values change drastically from our splines. We have more clusters of points that are associated with each other. Kriging also takes into account space between space to see whether or not these points are sharing some kind of relationship. So then for deliverable one, you're going to be exporting a two-panel map displaying the results from the kriging and spline analysis. Moving on. We can use the IDW tool for step 4. So then all of these interpolation methods have various settings that can be changed to influence the output raster. So we're going to be using our IDW. We have our ripple, and we can change the power from 2 to 1. Let's make sure to update the name for this. So this will be ripple Q4, and we're good to run. And then let's check out our new IDW and our old one. So this is my IDW ripple 4 and the old one. So this new IDW with the lower power, it's a little bit smoother in comparison to our old IDW. And if we keep on checking, we should be able to see that we do lose some associations between points, specifically in this area. So depending on the method used, we either gain more insights, more points, or we lose it. So more things to keep in mind. Following that, you're going to export a 2-panel image displaying the results of the IDW analysis with 2 different power settings. So power 1, power 2. Next, we're going to be using the IDW, spline, and kriging tools to create 3 interpolated rasters from the value column of our ripple feature class, and the same thing from our ripple rand. So we've got ripple and ripple rand that we're working through. And let's get started. So IDW, our input point features will be ripple rand. The Z value field can be value. And our output raster, IDW ripple rand Q5. And then we can switch this to our ripple. We'll update the output raster names to just ripple Q5. And we can run it. And then we'll do the same thing for our kriging. So then we have our ripple rand going first. We have our z value field as value. Our output surface raster can be kriging ripple rand Q5. We're good to run. And then let's just make sure I've got this all correct. Okay. And then let's do ripple Q5. And then finally, well, last but not least, our spline. We have ripple, we'll do ripple first. Our Z value will be value. The output raster can be spline, ripple Q5, and we're good to run this. And then let's switch to ripple rand. Ripple rand Q5. Okie dokie. So at the end of us running through these tools, we should have 6 new layers. So 2 IDWs, 2 krigings, and 2 splines. We're told what these features will look like. The ripple feature class will resemble ripples that would form in water if you were to drop a rock in it. And B, the ripple rand will look very similar, but will have a slightly fuzzier appearance due to the addition of some randomness in the value field. So I'll leave you guys to go through these, just checking through for differences. Some of them are really, really apparent. Some of them might not be so, but oh, yeah, you guys shouldn't have any trouble pointing out differences. So let's move on to 6 and deselect the rest of these. So 6 asks us to create a new subset of data for our ripple feature class, as well as our ripple rand and precipitation feature classes. So we only want where our random field is less than or equal to 5. So we can go to our definition query for each of these layers and create a new definition query where our random is less than or equal to 5. We can hit apply, and then we're gonna do the same thing for ripple and precipitation. A cool shortcut, if you switch over to SQL, you can copy the syntax that gave us that definition query and do the same thing for the other layers. So copy and paste them into that SQL box. And that's a lot faster way to apply definition queries across these different layers. So with these all selected, we can see that we've got points showing up different places. So we're on the right track. Now we're going to be using our kriging tool for our ripple and ripple rand feature classes against the value field. So we're using our kriging, we're using our ripple rand, our z value field will be value, and our output surface raster will be kriging ripple rand Q6. Let's run this. And then let's switch to ripple, stay in value, and we'll delete the rand. Let's run this. All right, cool, cool, cool. So then looking at our results, ripple rand, we have areas of less concentration over here, or less change, and areas of higher change and concentration over here. Our positive values are our pink and white values. So then we have a high amount of variability here, or interpolation. So following that, we're going to use our raster calculator to subtract the kriging results in step 6a from the kriging results in step 5. This will give us a raster displaying the difference in results between the complete data set and the subset. So we have our raster calculator, and we're doing Q5 minus Q6. So then we are doing this for our kriging results. So then kriging ripple Q5 minus kriging ripple Q6, and we've got our kriging raster combo. Well, you can also just call this the diff raster too. Diff rip. And then, cool, we have our new raster. And let's do the same thing for our ripple rands. So we have Q5 minus Q6, and we have our kriging raster diff rip rand. And all right, this will be your deliverable 5 and 6. These two layers showing the differences between the two different, showing the difference between the two layers. Moving forward, we're going to be creating another definition query to subset our data further. So to do that, we are going to create a new definition query for our ripple feature class. So let's just deselect you. And let's open up our definition query for our ripple layer. And from here, we're just going to have where our random is less than or equal to 5, and our lat is less than or equal to 10, as well as greater than or equal to 40, in addition to our random field being less than or equal to 5. So we can either go through the arcade and set it up that way, or you can go to the SQL and add in a code block here. You can do it both ways. It should not affect your results, but I have my SQL query right here. Oh, actually, I'd recommend doing this. We're going to add on to this for the last step, so do it this way if you haven't already done it. If you have, it's all good. So let's press apply and OK, and let's see what we've got. We've got a lot of points north and south, but nothing really in the middle. So now we're going to redo the kriging with this new subset of data. Our z-value field should be value. Yep, and let's redo our output raster. So we have our kriging ripple, this is Q7. Let's run it. And all right, we have a little bit of like a cell division kind of thing going on here, but that's really because we have our points north and south, so it's to be expected. And then finally, we're going to use our raster calculator one more time to show the difference between this raster and the kriging result based on a full set of points in our ripple feature class from step 5. So then we're looking for Q5 kriging, and then we're subtracting Q5, or we're subtracting Q7 from Q5. So then this will be our kriging raster, deliverable 7. This is diff subset Q7. We're good to run. And all right, we've got a very obvious change detection in the middle, and it kind of stretches out from the middle as well. So then this will be deliverable 7. And then finally, let's work on our precipitation class. So let's deselect you, and then let's re-add you. If you remember earlier in the lab, we created a definition query for this layer. Let's go ahead and delete that. So we have our full points. Let's use our spline tool to visualize the spatial variability of precipitation. We're switching our z-value field to value. And let's make sure that we name this properly. So precipitation Q8. We're good to run. And all right. We've got clusters on the edges and intense concentrations of interpolation right here. We're going to further subset our precipitation data by adding on to that code block that we had earlier. So you can either do it through the arcade, which is totally okay, or you can do it through the SQL. Either or works, but this is the syntax you should be using. We'll hit apply and okay, and perfect. We've only got a few points left on the edges of our precipitation layer. We'll use our spline tool one more time on our precipitation to create a new raster. So we'll make sure that we use value as our z-value random field. This is our precipitation super subset. Let's run this. Whoops. And all right, we've got our new raster updated. And we're going to finally use our raster calculator one last time to get the difference between these two. So we have Q8 minus the super subset. We can rename this one more time. Split line raster super sub precip. And we're good to run this. This matches up with what we've been seeing with our precipitation values. So we have lots of change in this area and not so much out here. So then this will be your deliverable 8 and 9, and you'll be done. So then one last time, the deliverables for this lab is going to be the image of kriging and spline results from step 3, an image showing the differences due to the power parameter and IDW analysis from step 4. What did changing the power parameter in step 4 do? How did it change the way in which the IDW interpreted the data? What did you notice about the differences in results based on the different methods in step 5? Image of differences in kriging results from subsetting data in step 6. According to your image from step 6, was the ripple or ripple ran feature class more affected by only using a subset of the points? Why might this be? That could just be a visual inspection. 7, an image of the differences in kriging results from limiting the longitudes of data from step 7. Step 8, image of differences in spline results from step 8. And then step 9, explain some of the limitations of interpolation that you learned about in this lab. What types of data would be better or worse suited to interpolation? So yeah, lab 10, one last lab to go. But I hope this helps, and I'll see all of you on Thursday. All right, bye.